Hello everyone. So today's video is going to be about GPT-Neo transformer model, which is basically uh, an open source variant of the GPT-3 model, as you might be aware, which was released by OpenAI. So GPT-3 was able to do a lot of tasks with very minimal supervision. So it basically did not require any fine tuning as such. So GPT-Neo is an attempt to make a model similar to GPT-3 open source to the community. So this is a slight overview on the GPT-Neo model. So it was released by Eleuther AI basically. So these are the contributors: Sid Black, Stella Biderman, Leo Gao, Phil Wang and Conal Leahy. It takes its roots from GPT-2. It's a causal language model trained on the pile dataset. So let's scroll to the pile dataset once, just to give you an idea of how big the dataset is. Yeah. So the pile is basically an 800 GB dataset of diverse text for language modeling. It consists of 22 smaller high quality datasets combined together. So once it's pre-trained on such a dataset, it is able to have basically this robust benchmark of general cross-domain text modeling ability for obviously large language models such as GPT-Neo, as we shall see later. So it has basically so the categories include books, GitHub repositories, web pages, chat logs, medical, physics, maths, CS and what not, philosophy. So that's about Pi. So world knowledge and reasoning ability are some of the things which can be enhanced using this particular dataset. That is what is the claim of the authors. So let's move back to the GPT-Neo documentation. Yes. So this is basically the documentation given by Huggingface. So that is what we are going through. Just to have a brief idea of what GPT-Neo is all about. So again, the architecture is similar to GPT-2, except that GPT-Neo uses local attention in every other layer with a window size of 26 tokens. So in global attention, what happens is, so global attention. So basically, global self-attention, what happens is every word attends to every other word, right? So if you sort of have an attention mask, so every word, these are words W1, W2 till Wn. This is W1, W2, Wn. So every word attends to every other word. So it's basically an O of n square kind of an attention. Whereas in local attention, so it would basically be this block. A block of it would be considered, or basically we would consider a window size of 256 tokens. So that is what is local attention. So local attention is helpful when you have to scale the model up to various, like to larger input sizes, larger input sequence lengths, right? So moving on, this model was contributed by Valhalla, so kudos to that guy. Alright, so generation. So yeah, the crux of GPT-3 is that you give it anything. It's called prompt engineering, right? So you have some sort of a prompt in which you tell the model to do something, and based on the prompt it just outputs the value in natural language. So this generate function does exactly that. We use to generate text using GPT-Neo model, right? So this is quite an unusual thing. So as you can see here, the tokenizer is of GPT-2 and GPT-Neo for causal language modeling. So it uses causal language modeling, that is the attention mask. As I already told you, it's window, like it's a local attention, is a causal language model. That is it, like the or the like these past tokens, the future tokens are dependent on the past tokens when it comes to the attention. So that is causal, cause effect relationship. So you can look into that a bit more. So I'm just giving a brief overview over here. So this is the prompt. So basically the input ID is that then you tokenize the prompt. So it's a very simple Hugging Face API which is applied over here. So over here you apply the model.generate, in which you have the input IDs generated here. Okay, do sample equal to true is basically like it's basically like you sample the input IDs. I guess it has something to do with that engine. I'm not quite sure. And temperature of 0.9. So this temperature is really important when it comes to how random or whether you want the highest confidence tokens to be your input, or do you want to mix it up. This is temperature for you, and max length is obviously how much you want to generate. So I'm not really sure about this do sample, so please make sure to check that out, and maybe we'll come across that as we go forward. This is your generated text. Okay, so this is your GPT-Neo config. GPT-Neo config has very interesting figures, as you will see. So it has a vocab size of 50,257, which is similar to Roberta. Or also like similar to normal models as such. Attention types again. So it could be like could be global or local, right? So and here you pass the number of layers basically, right? So for a 24 layer model, it will be global attention, it will be global, 24. So that is what is this parameter over here. Hidden size. The hidden size is 2048. If you compare it to BERT and all, it is quite a leap in the hidden size. So more the size is more the capacity to generalize. Number of layers defaults to 24. Again, this is a huge leap from 12. Number of heads again 16, huge leap from 12 again. Intermediate size 8192. The dimensionality of the intermediate, that is feed forward layer in the transformer encoder. Okay, so every transformer encoder has a self attention followed by a feed forward. So this feed forward layer here is 8192, which is quite a huge size actually. This activation function is GELU new. So in general we have GELU, so it's a variant of that parrot. So these are all similar parameters. Maximum position embeddings is 2048. So this is a maximum sequence length. So long former is another like transformer model. That stands at 4096. But yeah, I don't know why this is a bit less than that. Maybe due to constraints of the attention complexity. Yeah. So type vocab size. So this type vocab size is basically the vocabulary size of the token type IDs. Yeah, the token type. Generally, it's like generally used when you are using 2 sentences, as far as I know. So these are all some more parameters. This is just simple initialization. Here comes the GPT-Neo model, right? So obviously it has a forward. So this is similar to any other transformer model as such. This is something new which I saw, past key values. So this contains pre-computed hidden states, right? Key and values in the attention blocks. So the key value pairs, as we all know in the attention blocks, if they are cached, basically pre-computed means cached, then it increases the speed of computation. be used to speed up, as I told you, sequential decoding. Sequential decoding is the thing like whenever you have some text and let's say you want to take predict the next word, and sequentially you keep like you keep the input going on, and then you take the output as the next word that comes after it, and again this comes over here, next word. This is how you generate the text. This is sequential decoding. That's what it should be. Yeah. So attention mask. So attention mask is, again, these things are common. These things are all common to. So here we'll be only discussing things that are specific to GPTNeo, right? These are all, again, like these are all quite common. Okay, so here GPTNeo for causal language modeling. Yes. So as I was saying, so what is causal language modeling? So causal language modeling as in means like causal, the word causal means it has a cause to which there is an effect, the cause effect relationship. So causal language modeling, you can look it up. As far as I think it has something to do with the future only being able to see the past, something of that sort. I'm not very sure. Alright, so these are again similar things. I'm not going through this. This mostly like, yeah, these are some most things that we can do using GPT. Sequence classification. So sequence classification, you must be knowing like this is a bit of a different thing. The GPTNeo can also be used for classification, whereas like it is based on GPT-2, which is used for text generation, right? So this is very close to GPT-3. So the sequence classification head on top, it uses the last token in order to do the classification, as other causal models. GPT-1. Okay, so it uses the last token. So as far as I know, the BERT model is the first token. This uses the last token. Right. That's nice. Okay. So here are similar parameters. Not going through that again. And so as you can see over here, like, hello, my dog is cute. If that's the input. And if it is okay, so this is also the similar thing, right? So yeah, so basically what we saw is a very brief introduction of GPTNeo. So GPTNeo is a conclusion. It's basically an open source version of GPT-3, right? And also it can be used for generating text, and it can be used for classification purposes. So basically it also uses you can give inputs as prompts, as in GPT-3. And one more thing about GPTNeo is that it is trained on pre-trained on an 800 GB dataset, file dataset, right? Which gives it its understanding of various domains of knowledge. And one more thing is that it uses local attention instead of global attention, right? And it also has this causal language modeling going on, which again, as I suspect it is, I feel, so it has something to do with the attention masks. So if the attention or this like second time step, it will depend on, like, it will attend to the first and the second, won't go for the third. The first one will only depend on first, third one will only attend to, yeah. So I guess this is, I'm not very sure again what is causal language modeling. It's something to do with, I think it's something to do with sequential decoding, like the only the past tokens can be used as input for the future token. So if I'm wrong, I'm really sorry about that, but that's my feeling about causal language modeling. Second, taking with a pinch of salt. So that's what I feel about causal language modeling. So yeah, so this was a very brief run on GPT-Neo. Thank you for watching, and I hope that you liked my video. And please suggest some feedback, because I think I can improve a lot on the content that I post. Thank you very much.